Hello everyone, my name is Sofiane ELBARKAOUI and I'm a PhD student at the University of Cadi in Morocco and the University of Florence in Italy. It's an honor to be here today and to present to you a part of my work during the PhD journey entitled Investigating Organic Loading Effect on the Biochar-Based Vertical Flow Constructed Wetland for Wastewater Treatment. To begin with the plan of the presentation, start by a general introduction, objective, materials and method, resulting discussion, and finally conclusion. As you know, the world is concerned about environmental pollutant resulting from industrial, pharmaceutical, and domestic activities contain a mix of various pollutants such as organic matter, nutrient, pathogen, heavy metals, antibiotic, and emergent contaminant. However, the traditional treatment approach that rely on the conventional materials such as gravel or sand often fail to completely remove these contaminants, allowing their spread into surface drinking in groundwater as well agricultural area. This can lead to a serious harmful effect on the human animals and the aquatic ecosystems, thereby highlighting the need for a sustainable and low-cost solution that support both energy recovery and effective water treatment. Furthermore, the main objective of sustainable development are to ensure investor access to water and to reduce environmental waste. An innovative dual approach combines the recycling of agricultural waste and its conversion into biochar for use as an adsorbent to treat wastewater. That creates a circular system and supporting resource conservation and environmental sustainability. So based on that, the present study was conducted to optimize the treatment efficiency in general construction wetland by investigating the impact of biochar addition on the treatment performance of the construction wetland, then explore the effect of increasing the organic loading rate on the treatment capacity of construction wetland. Now let's move to materials method. The present study the present experiment was conducted with the two constructed wetlands with identical characteristics except the filtration bed of the constructed wetland with the biochar, which filled with 10% of the biochar plus the rest with sand instead of 100% of sand for the control system CWC. The experimental period was divided into two distinct phases based on the organic loading rate. The low organic rate was 20 grams study per meter square per day from which operated with the sequential batch fill and rest mode with the 5 batch per days and a total influent volume of 5 liters per day in comparison with 1 day drying period. However, the high organic loading maintained the same condition except the total influent volume which was 15 liters per day. The biochar used in this experiment was produced from olive pomace using a tubular furnace at 590 degrees for a contact time of 2 hours and a heating rate of 10 degrees per minute, producing biochar with the properties that meet the parameters specified in the European standard for water treatment. Now let's look at the result, starting with the onset parameters. Regardless of the organic loading rate, to observe an increase in the pH, electrical conductivity, and dissolved oxygen after treatment. That's can explained by the biological oxidation dilution of the carbon salts from the bed and the strong hydrogen exchange capacity of the substrate. There is in the electrical conductivity mainly came from the oxidation of the organic compound during the treatment, and the batch feeding mode also play a role. However, when the organic loading rate was increased, the change in the pH electrical conductivity in dissolved oxygen became insignificant, likely because the higher feeding volume reduced the contact time between the effluent and the substrate. As for the total suspended solid, the system performed very well, regardless the organic loading rate or the type of the media used of, in the filter. We observe a strong reduction in the TSS concentration through the whole experiment. The contact wetland with a biochar consistently show a lower TSS concentration compared with the control, even when the high organic loading rate was applied. The TSS removal efficiency remains stable. That means the removal rate is more closely related to the inlet concentration rather than the loading rate itself. Moving to the chemical oxygen dominant COD, we observe also a significant decrease in the concentration after treatment, regardless of the operation condition. The COD evolution for three distinct phases: an initial lag phase with limited biomass activity, and secondly, the adaptation phase with improved performance, and finally, high organic loading phase where efficiency slightly dropped due to the high organic inputs. Throughout this study, the Biochar-based constructed wetland again performed better than the constructed wetland without biochar, thanks to the biochar properties such as the porous factor, surface functionalization, which enhance the organic matter absorption and create a favorable environment for microbial degradation. Now, when we look at the phosphorus spices concentration, their kinetic curve involved in a parallel way, showing strong reduction after treatment across all the conditions. And the low organic loading, the removal efficiency range was very high. It's up to 49 for the phosphorus and up to for the phosphate orthophosphate in the total phosphorus. At high organic loading, however, efficiency dropped to around 24 to 28 for the total phosphorus and 28 to 35% for the orthophosphate. This reduction can be attributed to the X-organic matter, which limited the absorption in the precipitation process and create more anaerobic conditions, reducing microbial phosphorus uptake. In general, the biochar show limited effectiveness in the phosphorus removal due to its surface properties, which have like low affinity and negative surface charge. Concerning the nitrogen compounds or the spices, the removal or the results show a clear decrease in the total nitrogen and ammonia nitrogen concentration in the effluent compared with the effluent. In the effluent compared with to the influent, regardless of the applied organic loading rate accompanied by a higher release of the nitrates throughout the whole study, the Biochar-based the system demonstrated high removal performance under both low and high organic loading conditions. That suggests that the ammonia oxidizing bacteria develop more dynamically and operated more efficiently within the biochar substrate, likely due to its for structure and favorable condition for microbial growth. Similarly, for the absorbance at 420 and at 254 nanometer, there is a higher removal, especially at 420, higher performance of the Biochar-Based vertical constructor with land. Moving to the last slide before the conclusion, the microbiological indicators show that the statistical analysis reveal a clear reduction in the total coliform, fecal coliform, in the fecal streptococcus after treatment, especially under low organic loading conditions. As conclusion, the integration of biochar into vertical follow constructor will significantly improve the removal of a key pollutant, particularly ammonium, total gated nitrogen, COD, total suspended solid fecal indicator compared to the sand, especially under low organic loading. I would like to thank my supervisors and my co-worker at Bowler University. Thank you for your attention. I would like to remind just and many thanks to the project of secure food for the feeding during this journey of the PhD. Thank you for your all. Good day.